Alrighty, folks. Let's start by taking questions from the assignment. So if you have any questions on 15 to 22, now's the time. Annika? 20? Okay. So let's see, what do we have here? So the first thing I'd want to do is identify which situation we have here. You could draw the picture, or you can observe that the labels for the side length don't match the label for the angle. So we know that this is a side angle side situation. And as such, we need to use the law of cosines to solve for the side z. Annika, you good with that reasoning? Okay. So I'm going to just type this all in one line in my calculator to find z. So I'm going to type the square root symbol in right away because I know that instead of z squared, I really just want z. So I have 13 square root 13 squared plus 20 squared minus 2 times 13 times 20 times cosine 108. And that gives me 2701. Okay, there. Okay. So that's one answer. And now I could use the law of cosines and do like a side situation, or I can use a law of sines here to find the next angle. It doesn't really matter. I'm going to use the law of sines here. When using the law of sines to solve a side angle side situation where I'm looking for an angle measure, I have to be a little bit careful. I need to solve for the smaller of the two angles here. So should I be looking for angle X or angle Y? X. How do I know angle X is going to be smaller than angle Y? Because side X is smaller than side Y. Exactly right. Everybody's okay with that plan? Annika, you good? Okay. Okay. So to solve for X, then I'll cross multiply, divide, and then take the sine inverse. So I'm just going to do that all in one step. So sine inverse fraction 13 times sine 102. And then 27. Oh, actually, let's use the full. I'll just do that. Gives me 2808 degrees. And then to find angle Y, I can just do 180 minus 102 minus 2808. So 4992. And those should be my three answers. And you said you saw what happened on your paper? That's a bummer, isn't it? Yeah. Okay. Who's next on questions from this assignment? Miguel? 16, you said? Okay. Okay, so first thing I want to identify is what situation this is. This is a side situation. I can tell because I'm given three sides. So before I go and try to solve this, I want to check quickly that this is a triangle. So since the sum of the legs is greater than the hypotenuse, I know this triangle exists, so I know there's an answer. So let's go ahead and find that answer. When solving a side situation, I want to find the biggest angle first. So that's going to be solving for angle y. I don't know why I wrote y there. I should have just wrote the number 12. I'm stupid. All right, to get solved for angle y, I'm going to do subtract 5 squared from both sides, subtract 10 squared from both sides, divide by -2 times 5 times 10, and then take the cosine inverse of that whole shebang. I like to do that all in one line in my calculator. I'd encourage you guys to do the same, as if you're using like the fraction commands and all that stuff, it really makes it hard to goof stuff up when typing into your calculator, because it's going to look exactly like it looks on your sheet of paper. So I get 100.95. So that's my first answer. Now I can either solve for angle x or angle z next. It doesn't really matter. To solve for angle x or angle z, I could use law of sines or I could use law of cosines. It doesn't really matter. I think law of sines is a little bit faster because there's less writing to do, so that's what I'm going to use. So I'm going to have sine of 100.95 over 12 is equal to sine of x over 5. When I cross multiply, divide, and take the sine inverse, I get sine x is sine inverse of 5 times sine 100.95 divided by 12. And I'll go to my calculator. Again, I like to do the same thing, do it all in one piece. And I'm going to use the whole decimal for that 100.95 by using the answer command. And that gives me 24.15. And then to find angle z, I can just do 180 minus the other 2. Yes, of course. And that gives me 54.90. Are you happy with that, Miguel? Okay. Did you see what happened? Cool. Okay. Other questions from this assignment? Overall, this is going pretty well, I hope. All right. So today, we're going to start by deriving the law of cosines here together. So I have a sheet to kind of help us work with that. Of course.
Bless you. Thanks.
All right. So let's look at this. find on the first page where it says prove and the formula that we're trying to prove? Can everybody find that there on the first page? So we're trying to prove a squared equals b squared plus c squared minus 2bc cosine a, right? What does this formula kind of resemble? We talked about this yesterday. The Pythagorean theorem, right? In order to use the Pythagorean theorem, what do we need to have? Right triangles. Everybody agree with that? So my plan for this proof then is going to be to take this triangle ABC that I've drawn and divide it into two right triangles so I can use the Pythagorean theorem. The question is, how am I going to divide it into two right triangles? Why would I want to split it at C? Why not use angle A or angle B? Sophie.
Both triangles can be possible. Good triangles.
Colette? Because side length C is the biggest. So, okay, so I think I understand what you're trying to say. One decent reason is that if we use angle C to do the splitting, the two triangles that we get the two right triangles we're going to get are going to be both contained inside of triangle ABC, I think is what you're trying to say. If you try to split at angle A or angle B, one of your triangles is going to also be outside of, or have part of it that is outside of the triangle ABC. That's a reasonable explanation. The other is that if I want cosine A in my formula, I certainly don't want to split up angle A, right? So I definitely wouldn't want to use angle A to draw this too. But yeah. So okay, so let's do this. And we'll draw a right angle. So here we're going to call this one triangle 1, and I'm going to call that one triangle 2. Sound good, guys? Okay. So what should we label this length on triangle 1? That base. Why x? Good. So if you look at the point C, the coordinate at C is x comma y, right? So that means we went x units over and then y units up to get to C. So that means that this side is x. What's the height of the triangle then? Y. Very good. Everybody happy there? What's going to be the base of triangle 2 then? C minus x. Do you guys see why that is? Because AB is C, and we're taking x away from it, right? Okay. Everybody happy how we've set this up? Now let's apply the Pythagorean theorem to each of these two triangles. Go ahead and write that down. So you're just going to apply the Pythagorean theorem to each of the two triangles that we've just drawn here. For triangle 1 and triangle 2. It's going to be like that one. Kind of, yes. All right, so what did we write for triangle 1? Good. X squared plus y squared is equal to b squared. I agree with that. What did you write for triangle 2? Good. C minus x squared plus y squared is equal to a squared. Do you see anything in common between these two equations? They both have an x, sure. What else? They both have a y squared. So what we can do then is we can treat these as a system of two equations, and we can make a substitution via y squared. So it doesn't really matter which one we substitute in for the other, but there's definitely one choice that's a better choice than the other. Should I be trying to substitute equation A into equation B, or equation B into equation A? So I labeled them as A and B here. So did we make a decision which one's going to be more convenient? A into B. Why is A into B going to be the better choice? They're the same difficulty.
Because of the C minus x squared.
Look at what we're trying to prove. We want to have the a squared by itself, right? Look at equation B. It already has the a squared by itself. So that's the good reason as to why I'd want to put A into B, is because it keeps the a squared by itself, which is what we need to have in our final answer. Does that make sense? All right. So to be able to do this substitution, I'm going to rearrange equation A, so that I can get the y squared by itself. And then when I make my substitution, I have that. And actually, I'm going to write the a squared over here. Is everybody okay with what we did there? Okay. What do you think we should do next? Good. Well, let's FOIL out the c minus x. So when we do that, I get c squared 2cx plus x squared. Is everybody happy with that? Did you notice anything here? Yeah, the x squareds are going to cancel out because I have a positive 1 and a negative 1. Now let's compare this to what we're trying to prove. So I have a squared. I have the b squared. I have the plus 2c squared. I have minus 2c. Somehow x needs to turn into b cosine a. Right? If we compare this to what we're trying to prove, the only thing that's different is that we have an x instead of a b cosine a. Does everybody see that?
Yeah.
All right. So let's look for how I can turn x into b cosine a. Who has an idea of how we might be able to do that? My hint is to look at triangle 1. Because triangle 1 contains x, angle A, and side B.
No, because x equals b cosine a.
What?
You just write it down.
You just write it down. No, that's not how that works.
X over b is cosine a.
Okay, why is that true? Exactly. Yes, very good. Because this is a right triangle, we can use SOHCAHTOA. The cosine of A is adjacent over hypotenuse. Right? And then if we multiply both sides of this by B, we get that B times cosine A is equal to X. So then if I call that equation C, if I plug equation C into this, I have exactly what I need. No, you have to justify why that's true, which is what we did up there by using SOHCAHTOA. Cosines A. It's exactly what we had up above. So good job, guys. We did one of these together, right? That was fun.